Ideal Zarif 2023 year sewing technology. This revolution in straight stitch sewing. The world's first Ideal Zarif 2023 year double thread chain stitch technology with rotary looper. Large-scale replacement of lockstitch type 301 with a new double thread chain stitch type 401. Inventor, PhD Zarif Sharifovich Tajibarev, mechanical engineer, founder and director of Zarif Sewing Machine Company, Limited. Fundraising campaign to bring to market the Ideal Zarif 2023 year sewing technology. That revolution in straight stitch sewing. In 1994, we revolutionized sewing technology with the creation of the Zarif double thread chain stitch technology using a rotary looper. This breakthrough was officially recognized in 2000 with US patent number 6095069. It has taken us almost 26 years to perfect this innovative technology, making it the world's first ideal solution for sewing straight stitches. To achieve this, we first developed a prototype Zarif sewing machine based on our new technology in 1997. We modified an industrial lockstitch sewing machine, Class 1022, Orsha, Belarus, to carry out our initial trials. Through extensive testing, we identified areas for improvement and gradually improved the machine by applying our expertise. Finally, in 2023, we successfully created the world's first Ideal Zarif technology for straight stitch sewing. We now need financial support to develop an industrial version of the Zarif sewing machine based on our prototype and to start production to bring it to market. We have set up a fundraising page on our company website where anyone can make a contribution to help us bring our innovative product to market. We need your support. You can donate any amount to help us reach our goal. If your donation is $10 or more, you'll automatically receive a pre-order for the industrial version of the Zarif sewing machine at a 10% discount as soon as it's produced. The number of discounted machines you can purchase depends on your donation. For example, a donation of $50 entitles you to 5 machines at a discounted price. Why Zarif sewing machine? The Zarif sewing machine is the world's first machine with a very simple mechanical design. It can sew a wide range of materials up to 8 mm thick with a short needle bar stroke of 32 mm without any adjustments. It ensures consistent stitch quality without skipped stitches, thread breakage, needle breakage and needle point deformation. What's more, the machine allows you to easily switch between needle sizes from number 130 to number 60 without any adjustments. You'll also be the first to sew with our new double thread chain stitch, type 401, with loops turned 180 degrees so that the underside of the chain stitch seam looks more like a thick thread along the seam than a chain of threads. You will also be able to join any materials tightly for the first time with a chain stitch seam and tack the end of the chain stitch seam securely with condensed stitches of 0.5 mm stitch length. Early access for supporters. Anyone who donates $10 or more will receive exclusive early access to the industrial version of the Zarif sewing machine at a reduced price before it's available to the public. This ensures that our early supporters can benefit from the innovation they have helped bring to life. Join us in advancing sewing technology. Your support will help us revolutionize the sewing industry. Together we can bring the Zarif sewing machine to market, offering an innovative solution that delivers superior stitch quality, versatility and simplicity. Help us make this technological breakthrough a reality. Our Ideal Zarif 2023 year double thread chain stitch technology has revolutionized sewing machine design and straight stitch sewing. Eternal disadvantages of existing technologies for forming lockstitch type 301 and double thread chain stitch type 401. The eternal disadvantages of the technologies of the lockstitch and of the double thread chain stitch when using a looper that carries the bottom thread. The eternal disadvantages of lockstitch technologies that are linked to the use of the hook. Attention, no matter how much lockstitch technology is developed in the future, it will be technically impossible to obtain a lockstitch by feeding the bottom thread into the hook from a large bobbin instead of a small bobbin. ID is to exclude frequent changing of the bobbin with the bottom thread located inside the hook, nor will it be technically possible to obtain quality sewing of various materials with different thickness, density and stiffness without adjusting the normal tension of the top and bottom threads. Only our revolutionary Ideal Zarif double thread chain stitch technology of the 2023, using a rotary looper with a small needle bar stroke of 32 mm, is capable of sewing quality straight thread seams on various materials up to 8 mm thick with different thickness, density and stiffness without adjusting the normal tension of the top and bottom threads, which we have spent approximately 26 years developing. Technologies of the lockstitch type 301 with different types of hooks. In all types of hooks, it is essential to change the bobbin with the bottom thread inside the hook regularly. Due to the limited amount of bottom thread available in the bobbin, all automatic bobbin changing devices are very complicated and expensive, which increases the cost of the machines. When using all types of hooks, it is necessary to adjust the thread's tension to ensure the interweaving of the threads in the middle of the sewn materials, when changing the thickness, density, stiffness and elasticity of the sewn materials, as well as when changing the thickness and type of sewing threads, as well as to increase the density of the join of materials, the smoothness of the seam on light materials and the elasticity of the seam on elastic materials. When using all types of hooks, the thread take-up cannot smoothly tighten large loops of the top thread after the maximum expansion of the hook, because the thread take-up must quickly start to tighten the loop of the top thread to have time to feed the top thread to the needle before the needle point makes the next piercing of the material, and all types of thread take-ups that have an eye for threading the top thread have a mechanism that requires lubrication, and rotary thread take-up that have no mechanism can only be used for sewing lightweight materials. All types of hooks have complex designs and are made up of many parts. All types of hooks have a sliding area, as they have both fixed and moving parts, and their sliding areas must be lubricated, which can be done manually or automatically. The automatic lubrication system for the sliding area complicates the design of the hooks, making them more complex. All types of hooks have both fixed and moving parts, which can cause thread segments to be caught between them, resulting in the hook jamming and the sewing machine stopping suddenly. All types of hooks have a limited life due to friction in the sliding area between the fixed and moving parts of the hook. All types of hooks do not guarantee sewing without skipping a stitch, which occurs when the hook point does not enter the loop of the top thread formed by the needle when it is lifted from its lowest position. For all hook types, when changing to a different needle number, ranging from needle number 130 to needle number 60, it is necessary to adjust the hook in relation to the needle, as the maximum permissible gap between the hook point and the needle is 0.15 mm. When using all types of hooks, it is not possible to guarantee sewing without breaking the needle or deforming the needle point, as the needle comes very close to the hook body when it moves downwards, and thus bending the needle could cause it to collide with the hook body. All types of hooks consume a considerable amount of the top thread. As a result, each part of the top thread before entering the stitch repeatedly passes through the material to be sewn, the needle eye and the thread guides. This leads to wear of the top thread and a reduction in its strength. As the size of the hooks and the sewing speed increase, the loss of top thread strength during the sewing process also increases. For sewing thick and heavy fabrics up to 8 mm in thickness, using all types of hooks, the sewing machine needs a large needle bar stroke, greater than 32 mm. The eternal disadvantages of double thread chain stitch technologies that are linked to the use of the looper carrying the bottom thread. Attention, no matter how much double thread chain stitch technologies with a looper carrying the bottom thread are developing in the future, it will be technically impossible to obtain a tight materials joint with the double thread chain stitch type 401, nor will it be technically possible to obtain a quality sewing on different materials with different thickness, density and stiffness without adjusting the normal tension of the top and bottom threads. Only our revolutionary ideal Zarif double thread chain stitch technology of the 2023, using a rotary looper with a small needle bar stroke of 32 mm, is capable of sewing quality straight thread seams on various materials up to 8 mm thick with different thickness, density, and stiffness without adjusting the normal tension of the top and bottom threads, which we have spent approximately 26 years developing. Double thread chain stitch technologies using 3 types of loopers carrying the bottom thread. All 3 technologies using 3 types of looper carrying the bottom thread are not able to join the materials tightly with a chain seam and reduce the thickness of the underside of the chain seam. This is due to the fact that 2-stage tightening of the top thread loop located in the previous stitch. In the first stage, the top thread loop is pre-tightened with a needle as it moves downwards from the moment when the top thread loop is taken off the looper body until the needle reaches its lowest position. Then in the second stage, the top thread loop is finally tightened with the looper body on which the top thread loop is located, as looper moves along the seam in the opposite direction to the material feed by the length of the stitch. This technology is not able to greatly tighten the loop of the top thread in stitches, therefore it is not possible to tightly join materials with a chain seam and to reduce the thickness of the underside of the chain seam to increase its abrasion resistance. This limits the scope of application of a double thread chain stitch type 401. All 3 technologies using 3 types of loopers carrying the bottom thread are forced to use a needle with 2 long grooves. This is due to the pre-tightening of the loop of the top thread located in the previous stitch with a needle during its downward movement. From the moment the loop of the top thread is reset from the body of the looper until the needle reaches its lowest position, requires the use of a needle with 2 long grooves in order to reduce the friction between the top thread and the material being sewn. Such a needle with 2 long grooves is less resistant to longitudinal bending than a needle with 1 long groove. All 3 technologies using 3 types of looper carrying the bottom thread are not able to join combinations of different materials qualitatively. This is due to the fact that the thread take-up feeds the top thread into the needle until the top thread loop is released from the looper body. Then the needle begins to consume the top thread by reducing the size of the top thread loop in the previous stitch. The presence of a second, long groove in the needle helps to reduce friction between the top thread and the material being sewn at the point of needle penetration, but at the point of the previous stitch, friction between the top thread and the material cannot be reduced. Therefore, when sewing combinations such as textile leather, textile plastic, knitwear leather, or knitwear plastic, the friction between the top thread and the sewn materials increases significantly, as a result of which the needle cannot perform the first step of tightening the loop of the top thread qualitatively, and as a result, the second step cannot be performed qualitatively, which prevents the use of the double thread chain stitch type 401 for joining a combination of different materials. All technologies that use loopers that carry the bottom thread are not able to sew double thread chain stitch of high quality on different materials of different thickness, stiffness, and density without adjusting the normal tension of the threads. All technologies that use one of the 3 types of loopers carrying the bottom thread is unable to guarantee sewing without causing the needle to break and deform the needle tip. This is because the needle passes very closely to the body of the looper as it moves down, and so, the deviation of the needle may lead to it colliding with the body of the looper. All technologies that use one of the 3 types of looper carrying the bottom thread cannot guarantee a quality chain seam, because a stitch may be skipped if the point of the looper carrying the bottom thread does not pass through the loop of the top thread created by the needle when it is lifted from its lowest position, and also if the needle carrying the top thread does not pass through the triangle of thread formed by the bottom thread, the looper body and the loop of the top thread on the looper body. The technology is capable of reducing the length of a double thread chain stitch to just 1 mm, but it is not possible to reduce it to 0.5 mm to increase the reliability of tacking the end of the chain seam from unraveling by condensation stitching, because when the stitch length is reduced to 0.5 mm, the chance of skipping a stitch increases due to the reduced area of the thread triangle that the needle must pass through to avoid skipping a stitch. All technologies that use one of the three types of looper carrying the bottom thread are forced to use movable and immovable needle guards to increase the reliability of the stitch formation. The technology of forming a chain stitch by means of a looper, which carries the bottom thread and makes spatial movements along a complex ellipsoidal trajectory, uses a very complex mechanism. For all three types of loopers carrying the bottom thread, when changing to a different needle number, ranging from needle number 130 to needle number 60, it is necessary to adjust the looper in relation to the needle, as the maximum permissible gap between the looper point and the needle is 0.15 millimeters. For sewing thick and heavy fabrics up to 8 mm in thickness, using all three types of loopers carrying the bottom thread, the sewing machine needs a large needle bar stroke, greater than 32 mm. History of Zarif double thread chain stitch technology with rotary looper. In 1994 we came up with the idea of creating a double thread chain stitch type 401 using a rotary looper. We applied for a patent for this new Zarif double thread chain stitch technology, and in 2000 US patent number 6095069 was granted. Before our invention, the rotary looper was used in the single thread chain stitch technology, type 101, on single thread chain stitch sewing machines and button machines. History records that the rotary looper was invented in 1857 by the American inventor James Edward Allen Gibbs for his single thread chain stitch sewing machine, based on the single thread chain stitch technology, type 101, where the rotary looper makes 1 revolution per needle cycle. See US patent number 17427. A rotary looper is a unique and the only tool in sewing technology that can rotate loops of thread around its body by turning them 180 degrees with its tail. As is known, the rotary looper is made in one piece and has 3 zones: the head zone with a front tip to catch the thread and a rear tip to release the thread loop from the body of the looper, the tail zone for rotating the thread loop through 180 degrees, and the shaft zone for attaching the looper to the machine. The use of the rotary looper in the Zarif double thread chain stitch technology has enabled us to create the world's first new double thread chain stitch type 401, in which the loops of the top and bottom threads are rotated by 180 degrees. The Zarif double thread chain stitch technology forms a double thread chain stitch type 401, where the rotary looper makes 2 revolutions per needle cycle. Zarif double thread chain stitch technology with rotary looper, invented by us in 1994, see US patent number 6095069. In the Zarif double thread chain stitch technology, the top thread is fed to the looper by a needle with a vertical reciprocating motion, as is usually done. To feed the bottom thread to the looper, a bottom thread pusher is used, which makes oscillating movements in the horizontal plane. Since the rotary looper can loop thread around its body in the form of a loop, once the bottom thread, fed by the bottom thread pusher, is caught by the front tip of the looper, the top thread loop leaves the looper body and, as it tightens, forms loop from the bottom thread which the looper can now wrap around its body. As the rotary looper only uses a small length of the thread loops and the thread loops are released from the rear tip of the looper, the thread loops can be tightened very smoothly. Therefore, the Zarif double thread chain stitch technology uses a 2 rotary twin disc cam thread take-ups to feed and tighten both the top and bottom threads, with each thread being controlled separately. History of the prototype development of the Zarif sewing machine based on Zarif double thread chain stitch technology with a rotary looper. In 1997, we decided to build a prototype sewing machine to test our new Zarif double thread chain stitch technology with a rotary looper, which we had invented in 1994. We chose a Class 1022 lockstitch industrial sewing machine from the Belarusian company Orsha because it was widely used in Uzbekistan at the time and was relatively affordable. The machine had a needle bar stroke of 32 mm and was designed to sew fabrics of medium thickness. After a thorough review of the machine's design, we successfully integrated our new Zarif sewing technology into the machine, retaining only the mechanisms of the material feed, presser foot, and needle. Thus, in 1997, we produced the world's first prototype of the Zarif double thread chain stitch sewing machine with rotary looper. Trials on a prototype Zarif sewing machine allowed us to identify some of the shortcomings of our new Zarif double thread chain stitch technology developed in 1994. We then set ourselves the goal of improving our new Zarif sewing technology until it became the world's first ideal technology for straight stitch sewing. We have reached our goal in 2023. For about 26 years we have been researching and developing, successfully implementing many innovations and testing them on a prototype Zarif sewing machine. And so, step by step, we have come closer to our world's first ideal Zarif double thread chain stitch technology with rotary looper for straight stitch sewing. Stitch type, working units, and technical specifications of the prototype Zarif sewing machine based on the ideal Zarif 2023 year double thread chain stitch technology with rotary looper. The world's first prototype of the Zarif 2023 year double thread chain stitch sewing machine has an extremely simple mechanical design and forms stitches with high reliability and durability. The use of 3 rotary working units in the machine, such as the rotary looper and 2 rotary thread take-ups, together with a simple crank slider mechanism for the needle and the absence of needle guards, has made it possible to create the world's first prototype of the Zarif sewing machine with a very simple mechanical design. In addition, the machine is the first in the world to allow easy switching between different needle sizes, from needle number 130 to needle number 60, without having to adjust the position of the looper relative to the needle, thanks to the world's first increase of the maximum allowable gap between the needle and the looper tip to 0.5 mm. In addition, the machine is very easy to maintain as all working units are mounted on the ends of the shafts and can be removed without dismantling other parts of the machine. Kinematic diagram of the prototype Zarif 2023 year double thread chain stitch sewing machine. Our automatic thread trimming technology for the Zarif double thread chain stitch technology with rotary looper. It is well known that most modern industrial sewing machines are equipped with automatic thread trimming, and all automated sewing systems require automatic thread trimming. With this in mind, we have long been researching and developing automatic thread trimming technology for our Zarif double thread chain stitch technology with rotary looper. Thanks to these efforts, we successfully invented the automatic thread trimming technology for our Zarif double thread chain stitch technology with rotary looper in 2020, and further improved it in 2021 and 2023. The advanced version of our automatic thread trimming technology, which we invented in 2023, has not yet been physically manufactured to ensure its practical functionality. However, the drawings of our automatic thread trimming technology prove that it works in theory. At present we cannot disclose the details of our automatic thread trimming technology as it is not yet patented. However, we can say that the top and bottom threads are trimmed under the needle plate, with the bottom thread end remaining clamped under the needle plate after trimming. This eliminates the need to rethread the bottom thread when moving to the next sewing operation. If the sewing process is finished with condensed stitches of 0.5 mm stitch length and manual thread trimming, the resulting chain stitch seam will be difficult to unravel from the end of the seam. If the sewing process is finished with condensation stitches at a stitch length of 0.5 mm and with automatic thread trimming, the resulting chain stitch seam cannot be unraveled from the end of the seam, as the end of the top thread passes through the last loop of the bottom thread. Our ideal Zarif 2023 year double thread chain stitch technology with rotary looper opens a new era in the development of automated straight stitch sewing. It is well known that the future of mass production in various sewing industries is closely linked to automation, and the automation of sewing processes plays an important role in this transformation. Currently, some sewing operations are already being automated using robotic manipulator-controlled sewing systems. In the future, these robotic manipulators may be replaced by more advanced humanoid robots. When it comes to automated sewing, it is essential that the process is performed to a high standard, ensuring that there are no skipped stitches, thread breakage, needle breakage, and deformation of the needle point. Efficient sewing of different materials without the need for adjustments is also critical to the automation of the sewing process. Our ideal Zarif 2023 year double thread chain stitch technology with rotary looper for straight stitch sewing is the perfect solution to meet all these requirements. Our prototype Zarif sewing machine has proven this in practice, but only when the material is fed in one direction. This allows us to create different automatic sewing systems based on this technology, where the material is fed in a single direction. However, there are many sewing operations where the stitch must follow a complex path. In such cases, stitch formation must be independent of the material feed direction. With this in mind, we have been working for a long time to develop a device that would allow our Zarif double thread chain stitch technology with rotary looper to produce stitches regardless of the direction of material feed. As a result of our efforts, we were able to invent this device in 2020, improve it in 2021 and complete the final refinements in 2023. Although we have not yet built and tested the device, our drawings show that it theoretically works. Patent protection for our inventions that we invented in 2023. We intend to secure patents in several countries around the world for all our inventions developed in 2023, including the ideal Zarif double thread chain stitch technology with rotary looper, automatic thread trimming technology and the device that allows stitch formation with material feed in any direction. Advantages and disadvantages of lockstitch type 301 and double thread chain stitch type 401. Comparison of technologies for forming various stitches for sewing with a straight seam. Comparison of technologies for forming various stitches for sewing with a straight seam. Application of the revolutionary ideal Zarif 2023 year double thread chain stitch technology with a rotary looper that forms stitches in only one direction. Our prototype Zarif sewing machine, based on the ideal Zarif 2023 year double thread chain stitch technology with rotary looper, has proven its ability to perform straight stitching with material feed in only one direction and a stitch length ranging from 0.5 mm to 5 mm. In addition, we have developed a technical solution that allows the stitch length to be increased to 10 mm. Based on our ideal Zarif 2023 year double thread chain stitch technology, which forms stitches in only one direction, the following machines can be designed and manufactured. Various industrial sewing machines with different types of platforms and material feed mechanisms. Various automated sewing systems with material feed in one direction only. A range of programmable automatic pattern sewing machines with a 360 degrees rotating head that can feed material in any direction to create complex stitch patterns. Application of the revolutionary ideal Zarif 2023 year double thread chain stitch technology with a rotary looper, forming stitches in any direction. If the device we invented in 2023, which enables our ideal Zarif 2023 year double thread chain stitch technology with a rotary looper to form stitches with material feed in any direction, works successfully in practice, the following automated machines can be designed and manufactured on the basis of it, enabling the production of complex stitch patterns. Various conventional programmable automatic pattern sewing machines without a 360-degree rotating head. Various automated sewing systems. Single and double head quilting machines. Can our revolutionary ideal Zarif 2023 year double thread chain stitch technology with a rotary looper become obsolete in the future? We are confident that this will not happen. Our confidence is based on the following undeniable facts. The eternal disadvantages of the existing sewing technologies currently used for straight stitch sewing, such as the lockstitch type 301 and the double thread chain stitch type 401, prevent them from becoming the ideal solution for straight stitch sewing, no matter how much they evolve in the future. Furthermore, the invention of an ideal straight stitch sewing technology can only be achieved by creating a new double thread chain stitch technology that eliminates the eternal disadvantages of existing sewing technologies. Since it is technically impossible to invent an ideal straight stitch sewing technology by developing a new lockstitch technology without using a hook. However, the task of inventing a new double thread chain stitch technology and making it the ideal solution for straight stitch sewing is a very challenging one. All previous attempts to invent a new double thread chain stitch technology and make it the ideal solution for straight stitch sewing were unsuccessful. For example, the new double thread chain stitch technology using a special hook, see US patent number 3811392, 1974, was never commercialized. We believe that any new double thread chain stitch technology using a special hook cannot become an ideal solution for sewing due to the complexity of the special hook design and the need for lubrication. We were the first in the world to invent the new Zarif double thread chain stitch technology with rotary looper in 1994, which was granted US patent number 6095069 in 2000. It took us about 26 years to make this new Zarif sewing technology the world's first ideal straight stitch sewing technology. Threaded material joining is known to be the most universal method, as it allows for high-quality joining of different types of materials and their combinations in multiple layers, something that cannot be achieved with threadless material joining methods such as welding and bonding. Therefore, threading is likely to remain the main method of joining different materials in the future, as it is today. Our ideal Zarif 2023 year sewing technology aims to make thread-based joining more attractive and universal. Thank for watching. Subscribe to our YouTube channel.